Hi, everyone. Awesome to be here. I know we're kind of in a rush, so I'm going to dive right in. I'm going to tell you a little bit about MapD and more generally GPU-powered analytics. So using graphics cards to accelerate data warehouse and visual analytic workloads, literally getting 100x speedups over what you would get on a CPU solution. So we've all seen slides like this. Organizations are facing a deluge of data. Basically, it's doubling in less than every 3 years, or 40% year-over-year growth. Some of it is from traditional sources like standard enterprise or sales and marketing data. A lot of it is from social media, web click data, as well as kind of the broad rubric of IoT, whether that's sensors coming off of cars, industrial automation, cell phones, whatever it is, organizations are struggling to keep up. Storage is not the issue. So the price of storage has dropped precipitously. They're saying that by 2020, you'll be able to buy a terabyte of storage for less than $8. So putting it on disk is not a problem. People are building massive data lakes, Hadoop clusters, throwing their data on disk. But the issue comes when they try to analyze this data. So if data is growing at 40% year over year, CPU processing power is only growing at a 20% year over year rate. And this might be a little bit generous. This is if you take Intel's top line numbers and you extract every flop out of your CPU. So this compute gap is causing organizations to take all sorts of kind of awkward workarounds. People are downsampling, people are pre-aggregating, people are doing massive scale-out clusters of hundreds, if not thousands of nodes. And of course, that's tremendously expensive, and a lot of problems just don't scale well. You might double the servers, but not double your performance. So that's where GPUs come in. So GPUs were built originally to render graphics to a screen. People realized that rendering pixels to a computer screen was a fundamentally parallelizable problem. Later, NVIDIA developed CUDA, which was a general-purpose programming language for GPUs, and people started porting all sorts of algorithms to GPUs. First, scientific simulation, HPC, high-performance compute. More recently, machine learning. You've probably all heard about deep learning. And then finally, the final frontier is analytics, which is what we're pushing. So just to give you a brief rubric, on a typical CPU server, you might have 24 cores. On a GPU server, you might have 40,000 cores. So this is actually not representative. I think we'd need 24 of these slides to actually show the scale of the difference here. I'm not saying the cores are the same. Certainly they're not. There's a bit of a marketing battle between Intel and NVIDIA in this matter. But the fact of the matter is you can get a massive amount of parallelism running on a GPU server. In fact, you're basically getting a supercomputer in a box, something that would have been a top 10 supercomputer 10 years ago on a single server today. So that's where MapD comes in. So MapD was coming out of my research at MIT, was built from the ground up to leverage the massive parallelism of these GPUs to basically run SQL queries, analytic SQL queries, orders of magnitude faster than CPU solutions. So we've been independently benchmarked to be basically that much faster on a cost per cost basis. And because one of the killer apps for having such speed is slice and dice visual analytics, basically taking multi-billion or tens of billions of result rows and kind of visually exploring them at scale, we built MapD Immerse. So the cool thing about MapD Immerse is it can not only leverage the speed of the SQL on our back end, but it can leverage what these GPUs were originally designed for, which is actually to render graphics. So I'll get into that in a minute, but you can see that point map there. That's actually rendered right on the GPU. So MapD would sit in the middle of a standard data, kind of data analytics ecosystem, possibly pulling in from a data warehouse, pulling in from a data lake like Hadoop, alternatively pulling in streaming data. One of our clients is one of the largest social media companies in the world, and we actually pull in streaming data via Kafka. You can actually use this to run something like Tableau. You can use this as a straight database. We have people doing fraud detection on top of our system, just running very fast SQL queries. Or alternatively, you can use us with MapD Immerse, which is the visual analytics platform. I'll demo for you shortly. So one of the things that we did that was different than some of the people in the space is that we kind of built this from first principles. Basically, we have all these GPUs. We run on a server with multiple GPUs per server, up to 16. And what we'll actually try to do is cache the hot data, the data that you're repeatedly querying, in the GPU RAM itself. The great thing about video RAM or GPU RAM is that it's ultra fast. So we can actually, once the data is in GPU RAM, we can scan that data at rates approaching 6 terabytes a second. And that's why we can run queries over billions of records in milliseconds, even on a single server. What doesn't fit, we spill into CPU RAM. What doesn't fit there, we can spill into SSD. Ultimately, we can pull from your store of record, be that a data lake or data warehouse. But all of this happens automatically and intelligently for the user so the user doesn't have to think about it. And just one other quick thing. So the cool thing about MapD Immerse is when it's okay, we can actually render on the front end like another kind of BI or visual analytics platform. We'll take the results from the SQL query on the back end and render it with D3. When it makes sense, when you have big result sets, like you're trying to render every tweet or call data record, Verizon's one of our major clients, or you're trying to put all the census blocks on, or you're trying to do a big scatter plot, we can actually not only do the SQL query on the back end, but without even copying it to the CPU or to the client, we can actually render it in situ and bring a compressed PNG back to the front end. So you can have fully interactive viz at scale. And then we can do GeoViz compositing over a base map. How am I doing? Okay, I'm going to jump to a demo here, because demos are more fun than slides. Cool. Okay, I'm going to do a few kind of fun data sets. This is, you may have seen this, this is every taxi ride in New York City, released as a Freedom of Information request by the city of New York. It's 1.2 billion records. It's not giant, but it's relatively sizable. Particularly interesting here is that we're running this on a single server. And this is actually relatively small for us. So this data set would probably use a quarter of the capacity of a single server. However, if you were actually to use another system, a CPU-based system, you would need tens, if not hundreds of nodes to even try to get close to the performance, and you probably wouldn't even get there. So one of the first things to note here is that this is actually a example of back-end rendering here. So you can see here that we have all the taxi drop-offs colored by pickup borough. You wouldn't want to send 1.2 billion records over the wire, so we're actually querying it and then rendering it in place. A histogram of trip distance, basically a histogram of pickup time. And one of the nice things about MapD is that everything is cross-filter. So as I zoom in here, it's a little bit laggy. We're going coast to coast, and plus the Wi-Fi. But when I zoomed in, we actually queried the database live, scanned all those records, and updated the queries in real time. I could brush the trip distance histogram here, and we could see that the shorter rides are coming from Queens, the longer rides from Manhattan. I could brush the time histogram here, and basically we would see that this area right here drops off at the end of 2013, and I believe that's when they knocked down the Pan Am terminal. So our clients really like that the system is so fast and truly kind of at the speed of thought that it really basically allows analysts to kind of dive into a data that in a way that they wouldn't previously. So I could actually lasso this area, and we would do a geopolygon filter, and then I could see this drop off. We also made the system very easy to use. So if I wanted to add another chart, for example, say I wanted to look at the payment type over time, I could do that, turn that into a bar chart. The resolution here is pretty bad, so it makes the UI a little cramped. I can add it to the UI, and then I can immediately see that credit usage is going up over time, cash usage is going down over time. So it's very simple and easy to use, and our clients really like that. Similarly, imagine this was actually one of our, how can I call it, POC data sets for one of New York's largest hedge funds. And so this was kind of representative of some of the alternative data sets that they collect and bring to bear to try to make better trading decisions. So one of the things they might want to do, for example, a motivating use case, let's go into the Macy's in Queens here. So we zoomed in there, we can see the number of records over time. They may want to see how many taxis are going to, or how much foot traffic is going to this Macy's over time. And then they might say, hey, you know, maybe there's a decline, or and maybe, I shouldn't say short the stock, that's not PC. But you know, whatever they do, they might reevaluate their models. So I could lasso this area here, and then immediately, this is kind of the mall area. We can see that the peak pickup times are on the weekend, as you might expect. We could even get very granular and look at you know, Black Friday. So here we can see Black Friday, see how many rides actually went in November of, I guess this is 2014, and then we could compare it with this year. And then we might actually correlate it with stock prices or something similar. I'm going to do one other quick demo here. This is from one of our partners, Quandl. Quandl provides alternative data sets to financial services companies. One of the popular data sets that they have is a credit card transaction data set. So this is roughly 500 million records of credit card transactions pulled from people's email of course, the people signed up. But hedge funds buy this data so that they can do analysis of what people are actually buying. So here we have revenue by order date. Let's add merchant. I'll just do number of records. I'll create a bar chart here. And here you can see that we're doing a cohort analysis. We're making sure that the users were active before the end of 2014 and active after basically the end of 2016. So we're looking at a constant set of users. So here I can see already, I could look at Walmart. I could see that Walmart's probably having a very good quarter. This goes up to the end of last year. I could look at Home Depot, and I could probably see kind of a cyclical kind of, they kind of spike in the summer when people do home construction. Let's get another view of the data here. One of the great things about MapD is that we're not just pre-aggregating the data, that we're actually querying all the data live. So that gives us a full, we can look at the individual records. So here if I did order date, I'm going to look at merchant. I'm going to do title, and maybe I'll do price. So that's in our interface, and we can look at any of these kind of things. Again, I could click on Walmart, and we could see what people are buying at Walmart here. Okay, so that's pretty interesting. What if we wanted to look at a specific product here? So I'm going to do product title. I'm going to look at GoPro. So here we can see kind of an estimate of GoPro revenue over time through the lens of this data set. But immediately I would notice here that not all of this stuff is GoPro. So some of this stuff is just accessories. So I might add another filter here saying that it's more than $100. And so now you can see that all of these items are actually GoPros. And then finally, I might want to actually break it down by merchant here, so I can do that. And I will zoom in. And so here we can see that Amazon was actually their main channel for some time. But after a while, actually, Amazon declined, and Best Buy has kind of taken over to some extent. And it's kind of leveling off. So GoPro has not done that well, I guess, or at least the revenue hasn't risen according to expectations. So one of the great things is that behind the scenes, MapD is ultimately a very, very fast database. So if I wanted to, I could create a Python notebook out of this, basically pull the data. Here I'm using Facebook Profit to predict their future revenues over time. You can see that Facebook Profit thinks that the revenues are going to decline, and then I could do various types of regressions. So one of our clients really like that it's kind of usable as the full stack in the analytics pipeline. You can use it for the querying, you can use it for the viz, and one of the things that we're working on now is actually pushing machine learning onto the GPUs where you can do that right on top of the database. And so I think that is where we'll have a full integrated analytics stack that will be quite powerful for our users. 1 minute? Okay. I'll cut back to my... So just closing points here. We're at an inflection point where the growth in data is outpacing the growth in compute. And I strongly believe, I'm a little biased, but that GPUs are set to kind of become a dominant force in compute over the coming decade. They already are for things like machine learning, but I think across the analytics stack, you're going to see them become ubiquitous. Speed of insight is critical. So, just getting the insights, particularly if you're in the financial services space or a hedge fund, obviously there's a big competitive battle to who can actually get the tradable insights first. But even if you're a telco like Verizon, it's critical that if there's a problem in your network, you be able to diagnose that in real time and actually take corrective action. So Verizon, before using our platform, some of their queries over tens of billions of records of call data records would literally take an hour or more on a standard kind of data warehouse platform. And so they had no real-time visibility and were basically being reactive to problems in their network. With MapD, that's no longer the case. And we strongly believe in integrated analytics. By kind of building the full stack that does the SQL, the viz, and then eventually the ML, you can build something that's more powerful than the sum of its parts. Thank you.
Thank you, Todd. So just one or two quick questions from me, and then I'll pass it on to people. Is the data virtualized, or do you actually have to move the data?
Yeah, so you actually have to move. I mean, MapD essentially is a database, but we do have very easy ways to pull data from kind of a data warehouse. We have JDBC, we have a Hadoop connector, and typically people are looking at it as kind of a hot cache for their stored records. We're going to be building out functionality to make that even more transparent.
And so you should things like cohort analysis and that type of thing. So where do those algorithms come from? So you provide the computing power and the visualization, but where's the missing part in between?
The missing parts.
So how do you apply where does a cohort analysis algorithm come from? The cohort analysis?
Oh, cohort analysis. So that was all done in SQL. So
okay. So the somebody needs to add this.
You can do it, yeah. Our interface, if you've seen Periscope, we're very keen on giving users the full power, allowing a very basic, easy-to-use interface, but allowing you to do kind of advanced subqueries and stuff in the interface to do things like cohort analysis. We'll probably be adding functionality to make that a little easier for non-power users in the future because it's such a common use case. Cohort analysis.
And it's all cloud-based?
No, it's hybrid. So a lot of people run on-prem. A lot of financial service customers, U.S. governments, a big customer. These guys run on-prem. However, one of the great stories of 2016 is that all the major cloud providers, Amazon, Google, and Microsoft, basically added big GPU instances to their cloud. So we're making a significant push there as well. We have a lot of clients in the cloud.
Wait, do you have any questions? One over there.
Hi, great talk. I was curious if you have if you're using Tableau and the Tableau data extract is too clunky, would you then just do a live connection into MapD?
Over ODBC, absolutely.
Yep. Great.
So our clients, yeah, that's one of, Tableau extracts are great, but they kind of fall over either when the extract gets over 100 million rows, few hundred million rows, or when you have like streaming data going into the system. So that's one of the things I didn't mention is that we're very good at ingesting streaming data, and so people can put Tableau with a live ODBC connection.
Yeah, so great talk. I mean, obviously the way you're dealing with storage versus GPU, obviously it's make perfect sense. But it appeared to me that your technology is coming straight from lab in MIT. So what's your experience from lab in school? I mean, straight to the entrepreneur. I mean, what's the in and out of it?
Well, I just put on the hoodie and then I was ready. No, it's been a fascinating experience. So I started the first version of MapD for my final project for a database course at MIT under Mike Stonebraker and Sam Madden in 2012. Spun MapD off as a company basically at the beginning of 2014, and now we're about 30 people. Just closed another round of capital, and growing significantly, getting a lot of early traction. So it's been a blast, honestly. It's a different kind of hat you have to wear, but I'm still pretty involved in the technology and the product. Stonebreaker, yeah, I was under Mike Stonebreaker. Yeah.
Is that company 10 for Stonebreaker? That is like 10th company or 10th database company?
We're not a Stonebreaker. I mean,
you're not officially,
but we're not officially
okay.
a Stonebreaker company.
Good.
We're like the redheaded stepchild.
Hey, so the use cases you described seem to center around this idea that a business analyst or a human user would interact with the data, but obviously one of the benefits to corralling massive amounts of data is that a machine can interact.
Absolutely.
With it. Are you doing that? Is that sort of where you see this going, so that the business user wouldn't go onto your dashboard, but there would be some intermediate interaction with some sort of other intelligence level?
Absolutely. That's a great question. I think, frankly, you always need both. Machine learning has not gotten to the point where you can just point it at the data and say, give me the insights. People still often need to pick over it, look for anomalies, look for interesting trends. The hedge fund client I was mentioning does exactly this. We do have other use cases which are entirely programmatic. So fraud detection, we have with a major bank, basically looking at credit card transactions and looking at whether they're anomalous based on a user or a cohort's past activity, and there's a 50 millisecond window to do that. So that's a totally different kind of use case. But I think you need both. Humans are still going to be in the loop for this in the future.
One last question over there.
I'm curious, how well can MapD handle arbitrary computation? Because it seems like in your demo you gave a ton of like stuff that you've already worked on, producing plots and gating stuff. But if you wanted to sort of hand code an arbitrary thing to do something.
No, it's a great question. So right now it's basically SQL, and we do have a limited row-level UDF framework that you can actually put in. So anything you can do in SQL, you can do. We have a visual kind of UDF framework built on something called Vega, which allows you to kind of do arbitrary mappings of data to visual attributes, so you can get these nice plots. Kind of the next frontier for us is building out the pipeline where you actually can do full ML and allow full table-level UDFs. Probably first written in CUDA, but later maybe in Python, right on top of the database. The nice thing is we already have a compilation engine. I didn't have a chance to talk about it, but we already use LLVM to compile our SQL. So that gives us a path to actually being able to compile arbitrary code. So, great question.
Great. On this note, thank you very much.
Thanks, Matt. Yep. Cheers. Thank you.